Sorry about that. My first video got cut off, so I just want to finish up those last couple questions in this video. So I'm just going to slide on down to exercise 4. Now that we know the exterior angle theorem, we're just going to put it to work. So what this means now is the exterior angle, so outside of the triangle, 6x minus 32, is equal to the two that are not adjacent to these two angles. So x plus 3x plus 8. And once we know that, it's just a matter of solving algebraically. So 6x minus 32 equal to 4x plus 8. I'm going to subtract 4 from both sides to end up with 2x. While I add 32 to both sides, I get 40. And when I divide by 2, x is equal to 20. Now, in this case, I'm not quite done because remember, they asked me to solve for BCD, which is my exterior angle. So I'm just going to plug in for x. So 6 times 20, subtract 32. We're looking at 120, subtract 32, and that is going to be 88. Okay. So we always finish off by saying BCD is equal to 88 degrees. Something else that's useful about the auxiliary lines, like we used in our proof, it helps us find some unknown angles at times. So an auxiliary line can be used for us. So notice that we had 2 parallel lines, and it's an auxiliary line that's cutting these 2 angles in half. The reason why is because if I look at the shape I mentioned before in the previous video, we have alternate interior angles. So that angle is 35, while I have it again, so 41. To find the measure of angle W, I'm just taking those and adding them together. 41 plus 35. So angle W is equal to 76 degrees. We can see that again. In this case, we'll draw our own auxiliary line. So when I draw in an auxiliary line, it can just be somewhere that might be helpful. So I'm going to put that right through that angle I that we're looking to find. And I can extend parallel lines because parallel lines can technically go on forever. So I can use that and do the same thing we did before. And I can say like corresponding here. So, excuse me, that's supposed to say 117. So these two would be corresponding. But then angles on a line add up to 180 degrees, so this side could be 63. In that same thought process, I could take 129 and find the corresponding angle. And same idea, I subtract from 180 to get 51. And to find angle I, we just add 63 plus 51 together. So angle I in this case is going to be 114 degrees. You could have done it differently using vertical, and then the sum of the interior angles of a parallel line equals 180, anything along those lines. But auxiliary is just something you can use on your own to add